we're going to talk about precision and accuracy of a measurement. Those are actually not the same thing. Precision is the number of decimal places or the place value if it's larger than 1. So it's just a matter of how big or how small the number is in terms of its place value. In terms of accuracy, accuracy is literally the number of significant digits. That's it. So I'm going to turn the video off because I feel there's a lag in my recording here. I'll come back and say hello at the end. But anyway, precision is the number of decimal places. Accuracy is the number of significant digits. And if you understood what I just said, then you can skip 4 pages of reading. That's right, 4 pages of reading. I encourage you to read them. The author of the book does a fantastic job of explaining it and giving you more philosophical argument and also talking about a range of accuracy or range of measurement. But I'm just going to say it over here. Precision. Repeat what? Sorry, there's a lot of things I said. So precision is essentially the place value. Precision is the place value. Okay, just think of it as place value. It starts with the letter P anyway, right? Accuracy is a number of significant digits. Is that cool, Nicholas? Okay, good to go. So I'll just put that there. That little box there basically summarizes 4 pages of work. But now we're going to practice it. This is going to be a very straightforward discussion. You're literally just cherry picking numbers and place values. So if I selected questions 1 and 4 here just to get us going, it's unlikely that I'll ask you on an assignment, for example, to tell me the precision or the accuracy of a measurement. So these questions that we're going to do here, 1 and 4, which I've just extracted to this separate page, you may not get an individual question like this, because in my opinion, these questions are way too basic and way too short. Like, I'm going to ask you, what's the precision? That's it. I always incorporate precision and accuracy in broader calculations. So more likely, if you were to get a precision or accuracy question, at least from a chapter 2 level, it'd be like question 4. See, like, do these calculations and ultimately decide what the best course of action is for presenting your answer. So your answer will really depend on a couple of things: the monitoring what operations are there, and then making a decision on the operations themselves. So let's take a look here and talk about question 1. It says here, state the degree of precision for each of these measurements. So really what I'm asking you to do is tell me to what decimal place this is accurate. Sorry, is precise. I shouldn't use the word accurate. I'll help you out with the first one. So this one is precise to 0.01 inches, or 1/100th of an inch. You don't have to say it in English. You can just use symbols there. If you don't want to say of an inch, you can just say inches. You can just put this symbol inches directly. How did I get that? Well, just look at this number here and look at what the place value is of the last digit. Do you see that last digit? It's in the hundredths. So that's all it is here. See, it's in the hundredths. So all you're literally doing is telling me, or your audience, what is the place value of that last digit. So now that I got Nikolaos and Cosimo here hanging out, why don't either of you or someone else tell me the precision for the next question. So what would it be for this one over here? I'm just copying this text box. You got the right idea, but you're gonna always put a 1. You're gonna put a 1, okay? Because it's It's just the place value that you're specifying. Because this number here, it's okay, let me give you a better example here. Let's say you had this. I gave you the number 500. Where is this 5-digit? Where is the 5-digit located? Where is that 5 located? Is it in the ones, the tens, the hundreds, or the thousands? What would you say? Let me know in the chat. It's in the wait. The 5 here is in what place value? Is it ones, tens, hundreds, thousands? Thank you, hundreds, okay? It's in the hundreds. Now, when I say hundreds, how do you write hundreds in English? Or in math, sorry. You write it like this, 100. Agreed? Does that make sense? Good. It's the same thing here. I know that this 6 here, well, it's not in the hundreds, it's in the thousands. And thousandths as a number is 0.01 or 001, sorry. And you can of course write that as a fraction. Thousandths, because it's in the third decimal place. Cool. All right. There's no change on the screen. Refresh your screen or come back in and out of the thing, Matthew. But yeah, hopefully that worked. If it freezes on you, don't be alarmed. It freezes on me once in a while too. I think right around 10 o'clock on a Friday is pretty much a peak time for Blackboard usage. And of course, Blackboard's used by not just George Brown, but millions of people. So I don't know how much of a bandwidth it has to share. Anyway, how about this one here? Can someone tell us the answer here? Very good. Tamirlan, my friend, very good work there. Okay. Cosimo, Matthew, right on point, my friends. There we go. Okay, I'm just trying to clean up my mess here. There we go. So this is going to be 0.1 meters or 1/10 of a meter. Yeah, you can think of it as a column, exactly. I don't want to use the word column. I'm going to use place value, okay? Use the word place value. So the bottom line is, James, that you look at the decimal point and you look at how many spots it is. See, this one here is in the location of 2 positions after the decimal. So then over here you have 2 positions after the decimal. Or if you want to make it simple, you're welcome. Take the last digit and turn it into a 1. I'm not trying to say it to you like that because I want you to understand it on a deeper level. But literally, see this number here? Take the last digit and turn it into a 1. That's all I'm saying. That's like the cheapest way I can say it. But I want you to understand it better than that. That's why I'm giving you a more fulfilling explanation, hopefully. Okay, how about this one here? 7.21 meters per second. What's the precision on this number? All right, everybody's on track now. You can put meters per second like that, or you can just write it like that. You can write either way, full English for the units, or just the symbols for the units. 2.7 miles. What would that be? Yep. Or 1/10 of a mile. Okay, I think you're getting the hang of that. So we're going to talk about how you incorporate precision into calculations. So back here, I'm going to dig back here. This is on page 33. I've highlighted that. I want you to just read that to yourself. It's rule one of the two rules that you're going to see. So when you have decimals that you are adding or subtracting, then the answer should be presented to the level of the least precise of those measurements. So that sounds like kind of weird and annoying. Let me show you with an example how it's actually processed. So you see this question here involves subtraction A, and also C involves addition and subtraction. Those are examples of addition and subtraction, so we're going to use precision for those questions. So I'm going to highlight this in pink here because those ones are very similar questions. Let's take a look at each of these numbers. What is the precision for this one? Just like the previous example, what would you say? Just give me the decimal. Don't worry about the units here. What is the precision for this? Yeah, it's 0.1. I'll put it right there, 0.1. How about this one? 0.001. Thank you, Oakley. Okay, and the last one? What's the last one? Okay, very good. Now, out of those three numbers in purple, can you tell me which one is least precise? So which one is least precise? I have to type that, it's too slow. Yeah, thank you. Very good. So I'm just going to, the number that you said, 78.4, is the correct answer. 78.4 is least precise. And we know that the precision is 0.1. So what I want you to do is grab your calculator, and I just want you to do this operation. Don't worry about precision for a second. Just take these numbers and type them on your calculator and give me an answer, please, with all the decimals. What would that be with all the decimals? 95, 96, what is it? Anybody got an answer there? Oh, not 95. I'm subtracting. Sorry. Thank you. Can someone confirm? Thank you, Nicolaus. I was adding them. No, just subtract whatever it is. Do the operation as it is on the screen. Okay, so that answer there is just the raw answer. That is the raw answer. However, this answer doesn't make sense to present it the way it is because only the middle measurement was precise to 3 decimals. This one over here, very good, Oakley. Yes. What you want to do is you want to round this answer now to the least of the precise. So it's going to be 60.6 meters. So this is the correct answer. This is the most appropriate answer because we should go with the least precision of measurement. So this is how you actually use what I was saying earlier. Let me know there in the chat. Does that make sense? Cool. All right. Awesome, people. Okay, question C. Basically, we have a rounding rule. Nicely said, Nicholas. Now, this one over here is C is also, yeah, so you just round it to the set precision or the least accurate precision, we said. Now, take this number here, take these numbers, someone grab their calculator, and just add them up as raw numbers. Don't do any special stuff. Just take them on your calculator and perform the operation. Don't interpret it, just do it. What do you get when you take those numbers and process them? Thank you. Thank you, Cameron. Okay, now that answer is just the raw answer. We need to round it now. So when you look at the original numbers, which of these numbers is least precise? The middle one. The middle one. Oh yeah, Norris, you're ahead of me a little bit. Your answer's correct, Norris. Good work. Just answer that question for me first, though. Which of these numbers is the least precise? The middle one. So least precise is 7.890. So we're going to use 0.001. That's what I was saying. I can spell, I promise you. Oh, let's see. Are you kidding me? It didn't choose precise as one of the corrections. The joke. Okay, so thank you, Oakley, for that. It's what you did in the previous question, Cosimo, over here. Same idea. You look at each of them separately and just see which one is the smallest or the fewest number of decimals. We did it in the earlier question over here, right? So here this is 0.00001, 0.001, 0.0001. It's all good. It's all good here. So yeah, this is the one that's least precise. Matthew, it's the least precise. Use the word precise, Matthew, not accurate. Accurate something else. This one's the least precise because it has the fewest number of decimals. See that? The fewest number of decimals. Okay, so that's enough of precision. Two solid examples that you can review and make sense of. Also remember the the author of the book has other examples into this as well. Further to that, you can even Google or YouTube, or all kinds of people have done extra practice on these kinds of things. Like if you just look up precision practice, something like this, you'll find tons of these things on the internet as well. The author doesn't invest too much time in these ones here, but it is what it is. It's meant to be just a short topic and really will not dominate our discussion in the course. It's just so that you are aware of it if you are doing any type of scientific calculations. So now we're going to talk about what happens if you have multiplication or even division. So there's another rule here, which is on page 35. So when you are multiplying or dividing, you go with the least accurate of the measurements. In other words, we're looking at significant digits here. So when it says least accurate, we're talking about significant digits. So whenever you're multiplying or dividing, you should track not the decimals anymore, but the significant digits. So if I go to this question here, take a look at that question on page, question 4 in the exercises. Here we have three numbers that we are multiplying, but we need to consider for multiplication the number of significant digits. So I'm just going to write it on the side here. We should round our answer to how many significant digits. So this is what you need to figure out from the question. Because we are multiplying. Okay. I'll catch up to you in a second. I want to just walk it through with everybody here. So how many significant digits does each of these numbers have? Do each of these numbers have? How many significant digits do we have here? 4. 4. It's 4, right? We did this last time. You just count the number of numbers that are not 0. They're guaranteed to be significant. And if there are any zeros, then it wouldn't. Then you count them sometimes, and sometimes you don't. We talked about that last time. Hopefully, it pops up in the next example. Question B here. What's the middle one? How many significant digits is that? Thank you. And the last one is just 4. So, which of these numbers is the smallest? Which of these numbers here is the smallest? Is the 3, the middle one. So that's what you're going to do here. You're going to put 3 significant digits because you go with that one. It's the least accurate. It's the least of the accuracies. So once we have an answer, we're going to deal with that afterward and modify the answer. So just for a second, I want someone to grab their calculator and multiply those numbers, and I want you to read me all of the decimals that you get if they fit on the screen. Just tell me the whole thing, the whole number in its raw form. Like 400 something, I'm guessing. I don't know. I'm just guessing right now. 500. Beautiful. Thank you. I didn't even try to estimate it there, to be honest with you. I was just guessing a number. I didn't really extend my brain cells into that calculation whatsoever. So anyway, that's the raw answer. Perfect. Thank you for confirming. I'll ditch that 0 there. Okay. So how should we round the answer? What should we use? Okay, so Nicholas is saying that number. How many significant digits is your number that you type, Nicholas? It's 6, isn't it? That's okay. That's okay. I love it that people are participating. We're helping each other. Beautiful. That's the right answer. Good job. So the answer is 348 because 348 is 3 significant digits. So once you have an answer, you just chop it down to 3 significant digits. Yeah, it's not that. Yeah. So when you're multiplying and dividing, decimal is don't worry about decimals for multiplying or dividing. Worry about significant digits. When you're adding and subtracting, then you can worry about decimals. Exactly. Thank you, Nicholas. So there's another one here. So these are kind of alternating. I'm trying to do the accuracy ones in green and the precision ones in purple. Yeah. So if there's a decimal with 3 significant digits, you would have to do that. So Cosmo, good comment there. So for example, if it was like 19.5, 19.5 is what you would type. That's good. All right, let's deal with this disaster down here, and then we can move on to the next topic. You're most welcome. You know, it's good that you're asking these questions, everybody, because I remember when I was doing these kind of things in my science and engineering background, and no one ever really taught it. They just said do it, and then you just kind of have to wing it. So it's not really like, I don't know. You're not a psychic. I'm not a psychic. So it's good that we do a little bit to get confident. Anyway, I just wrote down the significant digits for all the numbers. And I'm just going to state here that our answer should be 2 significant digits. So this is 2. We expect 2 significant digits in our answer. So whatever you get on your calculator, first just multiply all that stuff out for me, please. So someone multiply all that stuff out. What do you get, like 9,000 or something? 9,361,4976. Thank you. And let's put a decimal in there. Thank you, Krushi. Welcome to the party. Okay. So what do we do with the answer here? Because this number is pretty big. So we talked about last time for large numbers. You're on the right track, Norris. Let me show you 2 answers, okay? So Norris and Nicholas are saying the correct thing. You should have a 9 and a 4. But you still need to have zeros here. These zeros, that's the answer. Thank you, Marco. These zeros here are not significant. These zeros are only telling you that the number is pretty big. It's in the hundreds or thousands in terms of the significant digits. Now, if that doesn't look appealing to you, you could also use scientific notation. So if you don't like one or the other, you could use scientific notation. The answer that I'm highlighting in red, these answers are both correct. If you prefer scientific notation, write it in scientific notation. If you prefer to write 9,400 expanded form like that, do that. What would I write? I would probably write this, just because it's not that large of a number, and to be honest, the significant digits don't intimidate me as much, so I'm comfortable with that. If it bothers you and you're not sure, and you just want to stick to something like 9.4, as like Norris typed in the chat, for example, then just use scientific notation, and that should save the day. So anyway, I hope that you had a meaningful understanding of how to process precision and accuracy. So now what we're going to do is deal with some calculations involving fractions and decimals, and also carrying over into measurement. Christopher, I think we covered a bit of scientific notation last time, but for the sake of today's class, I don't think we have enough time to cover that, because the main idea is that yeah, I think we have discussed it in the previous class. It won't interfere with the rest of today's class, though. Okay, so it would be in the previous lesson, if that's okay. Just a second, Christopher. Yeah, I'm just gonna open up a tab here, okay? Just give me 1 second, everybody. 10 to the 3, though, Matthew. What you have there, it's yeah, but the 9, Matthew. Just do me a favor, ignore the 4 for a second. If it was 9 times 10 to the 2, what would you have? If it was 9 times 10 to the 2, you'd have 900, wouldn't you? So that's why it doesn't make sense. The 0.4, ignore the 0.4, it should still be correct. I'm not asking you people to subscribe to a YouTube channel, but I'm just going to point out this one lesson here. This is from another course that I teach in the degree program. So if anybody here wants to learn about some of the stuff like the scientific notation, and also I do a discussion on significant digits, it's in this video right here. This is an extra video. This is from sorry. This is from a different course, but I'm gonna put the link in the I'm gonna put the link in our lecture here. So for those students that want to practice this a little bit more, I'll just insert a slide and I'll throw the link in here, okay? I don't want to put it in the Blackboard links, because people they'll look at the course and say that's the wrong course. So I have the link there. So if you want to practice significant digits a little bit more, and you want to see me teach scientific notation a little bit more, just watch some of that video. Just take a look at it for maybe the first 5 or 10 minutes of it, and it should hook up some better understanding. So hopefully that's good for you, Christopher, and anybody else too, moving forward. Okay, so we're gonna just go to some more practical conversions. Here we're talking about dealing with fractions, and also talking about how you would go back and forth between decimals and fractions. Something very practical, because you often encounter this when you're going from metric to imperial. So I'm gonna just scoot down here to page 42. Now, if you're wondering, why don't I read the notes? Respectfully, I don't really read the notes from the author, because the book is there for you to read it, not for me to read it to you. So what I'm trying to do is give you my take on it in kind of a summary form, so that we don't spend too much time of me just reading notes and not doing questions. So anyway, on page 41, there's a very brief set of questions involving decimal and fraction conversions. The emphasis that I want to make is on question 2. So you see these ones here. These ones are really, really key questions, especially for metric to imperial conversions, or within imperial, going from a decimal to a fraction. So I'm going to take a look at question 2, and we're going to just practice some of these things. We might do a couple of them because they are really, really, really useful questions. So take a look at this question here. It says find 0.287 inches to the nearest 1/16th of an inch. I'm sure many of you have a background either professionally or just casually in some type of a trade, including me. So like maybe you did some work in carpentry or tool and die, or you were doing something in machining, or who knows, mechanic, I don't know. So anyway, back in the day, I used to work on machines and small engines, things like that. So I never really saw a conversion to the nearest 16th of an inch because I wasn't doing any of that level of precision. But this is a very common thing to know how to do. For example, you might measure something with a device that gives you a decimal reading in inches or fractions of an inch, and then you need to convert it to 16ths of an inch. So anybody in the chat want to venture how would you do this? Anybody want to in the chat suggest how to do this conversion or to round it this way? What do you think? What could be one way we would do this? It's okay. We'll figure it out together. Nicholas, where did you get that number from? So Nicholas mentioned a very neat number. How did you get that number? What did you calculate? What did you type on your calculator? Perfect. So Nicholas is saying that 1/16 is 0.0625. This is actually a very, very useful way to do the conversion if you're not sure otherwise. So what you do is you say, look, I can just take this number here and I can count. So I can go 1/16, 2/16, and just see if I can figure out this number. You can see though, you will get the right answer, and this is kind of like a last resort if the number is really small, like 16ths or 32nds of an inch. But you can see that it will take you a while to get to this number, and I think the answer would be either 4 or 5/16, because I know that this number here, if I multiply by 4 or 5, I'm just doing quick mental math. I'm not doing it perfectly. I'm just guessing. Or estimating. I think that this is probably either 4 or 5/16, but I'm not sure, and that bothers me. So this is how you can do it without guessing and without counting it. So the cheap way to do it is 0.287. Oh, that's good news. Thank you. This is the cheap way to do it. I want to ask everybody a question quickly. When you multiply by 1, do you wreck anything? Does it wreck the number? Does it change it? Is good. Multiplying by 1 is the safest thing you can do in math, in my opinion. Exactly, Christopher. Christopher, your comment is very good. It looks like it's a quarter, and that will definitely help me estimate. But if it's out of 32, then I'm kind of in trouble, because then it's really, really small, the gaps between each of the decimals. So then I'm getting really perplexed about where to go. So instead of multiplying by 1, I'm going to do something weird. I'm going to multiply by 16/16. Now, why am I allowed to do that? Because 16/16 is 1, because the top and the bottom are the same. What is the advantage of this? Well, this 0.287, I could write it also over 1. And what I want you to do is remember our fractions work last time. So remember, when you multiply fractions, you do bottom times bottom. There it is. Can someone grab their calculator and multiply the top by the top? So do 0.287 times 16, please. What do you get? 4.592. Perfect. Now, take that number on the top, and I want you to round it to the nearest whole number. So 4.592, is that closer to 4 or 5? Congratulations, that's the answer. Pretty much, Oakley. You can decide like that as well. It's just that I don't want to count it up. I don't feel like counting it up. I want to do something that's like when the precision is so small that I don't have to count it up because it takes too long. But yeah, you could do that. So the answer to this question is 5/16 of an inch. Let's try this one over here. Using a similar logic. 0.824. So I could multiply it by 1, but 1 is boring. Doesn't give us much insight. So what should I multiply it by? Should I multiply it by 16 over 16? Is that a good idea? What should I multiply? There you go. Temirlan, my friend. Yeah, 32 over 32. Very nice. Okay, someone grab their calculator and tell me what the number is on top. Give me all the digits, please. What do you get? Awesome. So that's the answer. If I approximate that, that's 26 out of 32 inches. I'm sorry about the inches being this low. It's just I'm trying to type it instead of writing it. When I try to write it on the screen with that pen, it takes too long. Now, you could reduce this. You should reduce this. Oh, it actually made an exponent. That's cool. It actually grew a brain there for a second and did something useful. All right, hang on. If I go over here and hit the space bar, no, denied. Look at that. Denied. Yeah. Yeah, you should divide it by 2. I'm going to say reduce it. So 13 out of 16 inches. Of an inch, sorry. 13/16 of an inch. Okay. Well, I'm feeling pretty happy about how you're approaching these questions. So we're going to do one more of them, which is either C or D. Since I don't care which one we do, honestly, it's the same thing. I'll just do C. I'll just do C because it has the smaller fraction, and it's one that's less likely for you to do in your head. C for okay. My motivation was much more profound. Cosimo was much more internal, esoteric. But I'll take it, Cosimo. I'll take it. Okay, we're good. Now, what do you do with the whole number? Okay, so just put the whole part aside. I'm like getting all deep and philosophical, and Cosmo's like, yeah, C for Cosmo. Here we go. I like it. I like it. I'll take it. So anyway, put that whole number aside. So that 3 in the front, I want you to ignore it. We're just dealing with a fraction. So in this case, we would have 0.195 over 1 times, now I'm going quicker on this because you've earned your stripes here with me. Can someone type that on the calculator, please? 6.24. Beautiful. Okay, can someone round that now to the nearest numerator, to the nearest whole number? So that's 6 out of 32. Can someone reduce that? It's going to be 3/16. Too many ticks there, okay? So we're almost done. We just have to present the answer now. So now we're just going to go on the side here. This is the final answer because there is a whole part. So the final answer is 3 and 3/16 of an inch. And there you have it, my friends. That's how you do that one, okay? So you can do D on your own. Just do the same routine as I've kind of laid out with you in the previous questions. The whole number came from the question. There was a 3 here. See the 3 here? This question above didn't have it. It was 0 in the front. See, there was a 0, so there was nothing. It was just a fraction only. Now we have a full number, a whole number of 3 plus some fraction piece. So we have a whole number and a fraction combination. Is that okay? Okay. All right. So we're on to just the last topic here, which is a brief topic on conversions. So we're talking about converting between imperial between fraction and decimal form. So it's really just a continuation of what we've been doing in the previous in these previous examples. So the author talks about special fractions that you should memorize. Here, everybody should memorize or try to memorize. Now, if you don't remember sixteenths, I can respect that because I usually don't really remember sixteenths either. But I do remember eighths. I always remember eighths at least because eighths is the bare minimum. In terms of the time we have left, I want to spend it on the exercises on page 44, which is some conversion. See, convert to decimal feet, and then convert to feet and inches. So these are a continuation of what we were just doing in the previous examples. So what we just did for the past 10 minutes, we're going to do them again formally over here. So that's what I have set up here, and it's really just the last thing we're going to talk about in the chapter. I'm not doing this question with a diagram just because it's probably going to eat up all the time, and I want to do questions that you can refine your technique better, because I think that a lot of people coming out of first year, and not just in your program, in many programs that I've worked with, and also in the skilled trade school as well, which is even more alarming, like that, because they're building things with like pretty much coming out of first year. They need to know these conversions, and so do you. So I'm just going to cherry pick one of each of these questions. So we'll do like question 2. We'll do A, and then if we have time, we'll do B and C. But I'm going to go 2A, and then 3A, and then 2B, 3B, 2C, 3C, until we run out of time. So just give me a second while I modify this thing here. I just don't like how I set it up, that's why. Okay, here's question 2. Let's do part A. So we have 4 feet, and then 3 and 13/16 of an inch. And we're asked to convert that into decimal feet. So what kind of answer do you think, what do you think the answer is going to look like? So let me just make a suggestion here. The answer should look like this. 4.xxx. Actually, they're not all the same number, so I'll say x, y, z. There's just 3 digits here. Or you can put question marks. Probably question marks is better. That's what your answer should look like, okay? So everybody's wondering, what am I doing here? I'm saying to you, I'm just giving you a hint. I'm telling you that the answer should look like that. 4 point blah, blah, blah. And what you need to do now is figure out how to turn this fraction here, which is inches, and 3 and 3/16 inches, we need to turn that into feet. So we need to convert 3 and 13/16 inches into feet. So how the heck do you do that? Any suggestions in the chat? How do you convert 3 and 13/16 of an inch into feet? Okay, let me ask you a simpler question. Nicholas is on the right track. I like what Nicholas said there too. How many inches are in a foot? How many inches are in a foot? Thank you. That's how you do the answer. That's all you need to do, everybody. Don't overwhelm yourself. You need to do 3 and 13/16, and then divide that by 12. If you can do that, then that'll give you the decimal part. So these question marks here, see those 3 question marks that we're like trying to figure out? They're going to be based on this calculation here. So if you can figure out how to turn that into a decimal, then we're good to go. So I like the comment made by Nicholas there. So Nicholas, can you take 13 and divide by 16, please, and give me all the decimals? What's 13 divided by 16? Give me all those decimals, please. Or anybody else. Thank you very much. Okay, that's how you do it, everybody. Take the 13/16 and divide, do that division, and you get this decimal. See that decimal there, 8125. So now you know that this thing here, 3 and 13/16 is 3.8125. And then take that answer and divide that answer by 12. What do you get now? When you divide it by 12, what do you get? And just give me 3 decimals. Okay, sorry, give me all the decimals. I'm such a baby. I'm telling you, give me. May I please have all the decimals for that? Was just that, or are there more decimals? Okay, now you're talking business. Thank you. 770833. Okay, whatever. Okay. Thank you, Nicolaos. Okay. Round that to 3 decimal places. Perfect. 318. 318. So the final answer is this. Final answer is 4.318 feet. Why did I say 3 decimal places? Because in the question, let's get that highlighter out here. It says 3 decimal places. So that's why I went with 3 decimal places. You can barely read that. I'll just underline it in green. Exactly, Nicholas. Just adding back the 318, the 0.318 to the 4. Where are you confused, Cosimo? Talk to me. Okay, so this number here, yeah, you don't need to do anything with the 4 feet because it's already in feet. It's already in feet. This number here, Cosimo, and anybody else curious, this number is in inches. This number in the brackets is inches. And you have to divide it by 12. And when you divide it by 12, eventually you're going to get feet. Because there's 12 inches in a foot. And the 4 stays the same, yes, because the 4 is already in feet. Don't play with that number. It's already in feet. This part here, this part's good. Don't touch it. This part here, we need to turn it into feet. You're most welcome. It's not just your question. I know there's other people that aren't asking, so you're the brave soul that's asking all the questions. I like it. Okay, let's go to question number 3, and we're going to go the other way now. So what we're going to do in the next question, we've already done. We did it last time, but it's kind of just a little bit extra. So we're on the right track here anyway. So this may be our last example. Do you have class right after this? I'm sorry to ask you like scattered questions there. Do you have class after this? Yeah, so we're gonna wrap it up after this question. After class, I will turn this into a video and edit it. It'll be available on Blackboard and also on the channel as well. Anyway, we want to convert this into feet and inches. So the first thing I'm going to do is this, okay? The 1 foot is good. Don't touch it. Let's talk about 0.633 feet. What's 0.633 feet in inches? When you multiply it by 12, you get inches. So what's 0.633 times 12? Someone on their calculator, please. Thank you. Any takers on that? Thank you very much, Matthew. We've converted that to inches. So we know that the 7 inches is good. Don't touch it. The only thing we have to deal now with is the decimal piece. So take 0.596 and multiply it by 32 over 32. This is the part that we did last time in the middle part of today's lesson. Yes. Yes. So can someone multiply the 0.596 by 32? What do you get? Anybody? Oh, thank you. Sorry, my mic. Sorry, my speaker was muted for a second. I took the decimal piece over here. Adrian, I took the decimal part right here, and I used that. Just the decimal part. I'm just typing it on the. Your answer, Adrian, is being developed on the side here. Keep the whole feet. Don't touch it. Multiply the decimal feet by 12 to get inches. Keep the whole inches. Convert the decimal inches. Okay, so I've tried to give you a synopsis of all the steps that I did here. So I'm just going to recycle Marco and Nicholas's answers there. Thank you, guys. So that's 0.072. We're going to round that to 19 because we go with the nearest fraction. So it's 19 out of 32. And of course, that's in inches. So the answer, I'm not typing it in caps to yell at you, but it just looks cool. So the answer is 1 foot. Nice, Oakley. We get 1 foot, 7, and 19 out of 32 inches. Now I'm just writing the units in just in text instead of as quotations. There's my answer. I hope that you enjoyed that. If I have time in the next few days, I'm pretty slammed on the marking this weekend. I'm just gonna stop recording. Sorry. Just a second, everybody.